the screen? Just
writing part is here. So welcome all. This is the live session for this course, Design for Quality Manufacturing and Assembly. I see there are quite a few people on board. You can start typing in your questions, and as I get my questions, I will try to answer. Already I have few questions, but looking at the questions, it appears that people didn't understand what a live session is. So there is someone, Mr. Mohan has asked a question: what are the designing courses mechanical engineers should learn? This is a very broad question to answer, but from my experience in the Department of Engineering Design, I would say starting from strength of materials and fluid mechanics to design of machine elements and mechanics of deformable solids, and maybe a product design course is a good starter. And of course there are advanced courses like design for manufacturing and assembly and advanced structural mechanics or advanced fluid mechanics, because these are the fundamentals for designing. Then Mr. Mohammed has asked a question, synergistic and anti-synergistic, full explanation. I guess we covered this during the lectures using the pill example, meaning the tablet example. So if you have tablet A and tablet B, I'm going to just quickly write them. Let's say that you have tablet A and tablet B, and if you individually take tablet A, the pain is reduced for about 3 hours, and let's say that if you individually take B, the pain is reduced for 4 hours. Then in a synergistic situation, if you take both A plus B, then the pain is reduced for, let's say, greater than 7. Then it is synergistic. If it is anti-synergistic, it is going to be the less than the least, which is 3 in this case. So it will be less than 3. So this is the example of synergistic, and this is for anti-synergistic. See, synergy means what? It is when two components come together, there is a stronger benefit than the individual components themselves. So this is like a composite. And anti-synergistic is when two things come together, the resultant effect is less than even the minimum of the individuals. So that is anti-synergistic, that's all. The third question comes from someone called Anand. I don't know, the candidate has mentioned regarding design. I don't know what to explain for that. Then after that, Mr. Santosh says there are no questions. Indrajit Mondal says WB. Prashant says no. And someone has asked, what is a better program to do somewhere else abroad? Yeah, it depends on the individual's preference and the courses that are offered abroad. It's a very broad question and out of scope for this course and this discussion here on the live forum. Someone has asked, so practically they have given 3 questions out of assignment. So I guess you should just go back to the solutions that we have provided. That's or whatever, it would have come up in the once the homework deadline was over, the assignment deadline was over. So Sai Supriya has asked, what are the subtopics that you are going to teach? The candidate could have been a little bit more specific, because we are only going to cover topics. So far we have covered topics on design for quality and robustness. Next we will be covering topics on manufacturing is over. We'll be covering assembly and then design for sustainability. There are no subtopics per se under that. Pugarendi has asked what is the use of orthogonal array in robustness. I guess we have enough discussion on the lectures themselves, but the idea is simple. In a couple of lines, if I need to answer, orthogonal array is a template to do design of experiments. It's just a set of experiments, and there is some sort of a mathematics behind these orthogonal array. For instance, if you go into the lectures, you will understand that the concept of balance within a particular column and between any two columns, the number of repetitions are same. So those types of qualities are ensured in orthogonal array. So for each row in an orthogonal array, which refers to the number of an experimental, each row refers to an experimental combination. So you get the output responses using which you can, there are several ways in which you can achieve robustness by, again, orthogonal array is just a template that lets you conduct experiments to obtain responses. Further, you have to analyze those responses and try to look at reducing the variability. So that is a slightly different, not slightly different, it's one more level higher than that. So we have discussed about different levels and the line plots that you can do between the levels, from which you can even identify optimal combinations that are not part of your design of experiments. If it is not a full factorial experiment, then you might have combinations that are not there, as you might get them as optimal combinations. So if this question is not still clear, I mean, if I didn't address this clearly, then you can still drop a question on our forum, and we will try to get you additional details. Okay, now I am able to look at on the chat window. There is someone called Divi Patel, not able to answer a few questions of assignments. Well, I would say just good luck, try as much as you could, because we cannot help you there. The whole point is how much you learn in this course is what it is, and the questions essentially test you whether you have understood the concepts. So you always have the choice of going back to the videos, and these are oftentimes they are straightforward questions, so you should be able to answer them. Gopal Krishna, how can we say the optimal solution is correct by half or 1/4 factorial techniques? So this is a really good question, because, well, not really because, it's a good question. But the point is, what does one mean by the word correct? If you assume that you have a function, so this is slightly out of scope for our course, but then for the sake of discussion, I'm discussing this, right? So let's say this is x and this is f. The deal with this one is, this is where your actual minima is, which is the optima. But however, if your design of experiment points were at the points that are marked x, they were only there, then you are not going to be able to get those corresponding values. And even in a regression fitting situation, what might happen is you might get this dotted line approximation. So there is no guarantee that you are going to get the actual optimal combination, but given whether it is half or 1/4 factorial, it even refers to the fact that that is all your budget is. So based on the budget that you have, these are the best experiments that you can do compared to any other experiment, because of the factor of balance within a particular column and between any two columns. from that perspective, with only those many limited samples, and this is the best combination that you can get. And if you remember, we also talked about the stratification issues in something like orthogonal array. Because what happens is, if you generate 60 points in 3 dimensions, in a projection surface you get only 20 points information. So that also actually hinders the amount of information that you get out of 60 experiments. Though you have conducted 60 experiments, in a projection surface you get only 20 experiments information. Something else to add? Okay. So Varshil Shah asks, right now I'm in the last year of my project in MTech here, and I'm going to do, yeah, I mean, it doesn't matter where you are applying it, as long as the problem is about, or the challenge is about using DOE to obtain responses. Once you obtain the responses, there are multiple things that you can do. You can get the statistics of the responses, you can estimate the variance, you can estimate the coefficient of variation, you can try to do a robust design, or you can just estimate only the mean, the median, the variances, the 75th, 20th. So there are multiple things that you can do with that. So it is irrespective of what is the project that you are looking at. It could be a torsional spring, it could be a suspension, or it could be a design of a wind turbine. It does not matter. It could be anything. Alex, good evening. Yeah, good evening. So I think we are stalling on the number of questions. Are there other questions?
No, we don't see it.
Yeah, so I'm around. We will hang on until the session officially closes. So if there are additional questions, I'll be more than glad to take it. What is it? Madras and Co. Knowledge of GD, geometrical dimensioning and tolerance, is also must nowadays, sir. Can you suggestions in GD and T in DFM? Well, I think GD and T essentially plays a role in assembly rather than in manufacturing, because your tolerancing, and the tolerance is going to, or the dimension is going to affect mostly in the assembly part. So in principle it's slightly out of scope for this course GD and T, but as a subset it should affect only in your assembly. So there are different ways in which to account for tolerance. For instance, there is something called a stack-up model. Like if you are assembling 5 different parts, x1 plus x2 plus x3 plus x4 plus x5, then how does tolerance in each one of them affect the system tolerance? So there are different ways to deal with that. That is an area of research by itself. There is no standard procedures to do that. Different companies use different ways to deal with that.
Mostly guidelines.
Yeah, usually there are guidelines to deal with it. I mean, the guidelines are usually the worst case scenario. Then again, Alex is asking, what is the difference between factor and factorial? Well, you can think factor as factor is just an English word if you think about it. You know, factor is something, a cause, the variables that will affect your response. And factorial is again an English word, but in a mathematical sense. Like 2 factorial, 3 factorial, like that. We are using this in the context of design of experiment. So if it is a full factorial, means the number of combinations that you can have in terms of A, B, C. Because if you have like A, B and C, we have discussed this enough time in the course, but not explicitly under the name factorial and the difference and all that. If you have A, B, C, then you can have A, B, C separately. Then you can have A, B, A, C, B, C, and then A, B, C. So all this 3 plus 3 plus 3, 6 plus 1, 7 combinations are called the factorial. So this is called a full factorial experiment. and you can use a half factorial because in this, if there are 7 combination, you will have an L8. So half of L8, a half factorial of L8 will be L4. So L4. So yeah, so that's essentially the meaning of factorial. And factor is just using factor is because A, B and C are factors here, and using factor is what you define factorial. Sir, as you discussed in the lecture, how to formulate problem formulation. In mean how to put problem formulation.
I think it is how to put.
What is it?
I think it is I mean how to put.
Oh, I mean how to put problem formulation. Okay. I'm not very sure where this question is coming from, but from the point of generally from a problem formulation perspective, if you recall the kiln example that we discussed about, there will be a furnace and then there are bricks inside that. There is issue with the expansion factors and stuff like that. So if you look at that problem particularly, the issue is with the non-uniform heating. But the way in which we dealt with that issue in a robust design perspective was we never worried about the furnace or the source of heat. We told that the respective things will be the same, and you just have to make sure that your dimensions, you are getting the dimensions. So that is essentially the idea behind robust design. You are not eliminating the cause of the variation, but you are still going to reduce your variation. So irrespective of your input, your output variation is minimized. So in order to be able to do this, there are different ways in which you can look at formulating. For instance, one way of looking at it would be to minimize your variance or maximize your SN ratio, which is equivalent to because this noise is represented by your standard deviation. So since it's in the denominator, you want to maximize that. Or you can even do minimize the mu plus k times sigma. So there are different formulation techniques that you can do. Sometimes we even do minimize mu and minimize sigma. It's called a multi-objective formulation.
He expanded on the question.
So there are different ways of looking at the problem formulation itself. The idea that I would have told during the lecture is if you formulate the problem in an efficient way, then most of your computation time is taken care of. So I'm moving on to the next question. You're doing good. Give real life example to every concept. So really good. It is very easy to catch the concept. Thank you, Hari, for your comments. It would be helpful if you give us suggestions on where we could improve. It will be really useful. And the people, I am someone who come on screen, but there are a few people behind the screen who are my TAs and the students who have picked up multiple examples and given us, given me in terms of conducting the course. So I will take your kind words to them as well. Going back to the question again, okay, so Alex elaborates on his question in the paper helicopter model. Discussed how to formulate the problem. So if you look at the paper helicopter example, the idea was simple. You are going to make a paper helicopter and you wanted to increase in the paper helicopter, we wanted to increase the flight time. That was the objective. Okay, so increasing the flight time. If you look at it, we had different combinations, right? So we had like different factors, and then we had experiment 1, 2, 3, and then we had like different combinations, hence different experiments. So I don't know, let's say that we had about 32 experiments. Then we had your flight time. So there were flight time entries. But the deal is, for the same experiment, when you drop the paper helicopter the second time, you might get a different output. So what does that mean? That means that there is variability in the output. The output here is the flight time, even for the same experiment condition. So that is essentially the variability that you want to reduce. So if you are selling 5 different, not 5 different, 5 individual motorbikes of the same make, of the same brand, from the same dealership, they are likely to perform differently. Though my quoted kilometers per liter could be the same, they are likely to perform or give different mileages. One thing that we understand is this mileage is dependent on several factors that the producer or the manufacturer or the dealer does not have control, which includes who rides it, how they ride it, which road they ride it, where you put the petrol from, how often did you use the clutch, how often or how nicely did you use the accelerator. There are so many different factors that you don't have control on. But in spite of all that, irrespective of my input condition, I want my motorbike, all my motorbikes, to give more or less the same output, which is the kilometers per liter in this, the mileage in this particular case. So that is the whole deal about robustness. Okay, and with respect to the paper helicopter, what we wanted to do is we wanted to identify a combination of this factor that will give you the minimum variance in your output. That is only with respect to the variance. But there is also another factor. The moment you have greater than one response, you are worried. The first moment that you are worried about is your mean. So you always want to increase the flight time. At the same time, you also want to reduce the variability around the flight time. So there are two objectives that you want to do. And if you do any of these three things that we have discussed here, you can do a mu squared over sigma squared, or you can do a mu plus k sigma, or you could do a minimize mu, and or in this particular case you want to maximize mu while you are minimizing sigma. And the course, whatever we have discussed in terms of the in terms of the details that we have discussed with respect to this course, I think the SN ratio and how to obtain robustness using the SN ratio is what we have discussed. I hope this clarifies. Otherwise, Alex, I request you to elaborate a little bit more on your question, either in the current forum or in the course forum. How can we select OA for factors with different levels? Nafil is asking this question, which is a very important and interesting question. So if you take, I don't have the supporting material here to show, but if possible, we will we'll make a note that we will post a particular example in the forum. For instance, something to do with orthogonal array is there is enough research and scientific background for that, as people have shown for any number of factors and any combinations, the orthogonal array OA is available. The deal is, for instance, let's say that you have two factors with two levels and two factors with three levels. So 2 factors, 2 levels is 2 raised to 2. Then 2 factors and 3 levels is 3 raised to 2. Okay. So now 8, right?
2 cube is 8.
Yeah, so 2 levels, yeah, level time. So it's basically level times factors, not level times, level to the power of factors. So it's 2 raised to 2 times 3 raised to 2. In this case, it is 4 times 9, which is 36. So if you are using a full factorial design, then you are looking at L36 minimum. So the deal is, you can, if you take any book or online repository that gives you the stuff, it will give you L36 like this, and then it will tell you for what combination is this. Okay, so for instance, you can, maybe only this combination is possible, or there could be other combination. For instance, if you're talking only about 2 levels, then what happens is you can only have L4, then L8, then L16, then maybe 32, 64, it goes that way, right? So this 36, immediately when you say, it is clear that it is only a mixed formulation. That's what we saw. That's what we call it, mixed formulation. So the mixed levels is possible, and we will post an example in that case. Thanks, Nafil, for asking that question. Okay. In the DOE, we have to restore to the original at each trial. Varshil, it's not clear what your question is. In the DOE, we have to restore to the original one at each trial. Yes. Okay. Let me try to understand what you're trying to ask. You mean to say for the same experimental setup? That's what a DOE point means. Each DOE point refers to different experimental setup. A trial means executing that one combination once is one trial. So the same combination will be executed another time. That is your second trial. That is N trial. So I'm not very clear what you mean. If you retype you elaborate a little bit on that, I could probably explain what it means. Sharma is asking, good evening sir, I'm not getting orthogonal system. Problem in orthogonal resolution table, week 4, lecture 2 and 3. Mr. Sharma, you need to be a little bit more specific, because these are all 50-minute lecture, and this is a doubt clearing session here. I cannot be running so if you are very specific about what your question is, I'll be more than happy to handle the question. But the simplest way of looking at orthogonal array is the property that I have discussed. There is a balance with respect to the factors in a column sense and between any two columns. So that is the biggest advantage of an orthogonal array, because you are not biased. Because if you compare it with one factor at a time, or the better way of doing that, this orthogonal array gives you this balance. You are not biased against any particular factor. All factors are considered the same number of times. Similarly, all levels are also factored in the same number of times. So it is done. It's done that way. And if you have specific question, I can take an orthogonal array. We have also discussed the limitations of orthogonal array, if you see. The other one is, please explain the types of factor. You mean okay. So the different types of factors. Okay, so for instance, different types of factors. So one thing that we talked about is the continuous factor. See, I might not use the same terminology, but conceptually they are all the same, okay? So continuous factor is something like your time, for instance. Okay, time is an example. Temperature is an example. For instance, time, I can say like 22 seconds, 22.5 seconds, 22.8 seconds. 22.8 is a very small distinction, but you can say, like 25 minutes, 25.2 minutes, 25.4 minutes, all that, right? Similarly, the temperature, you can say 31, 31.5, 31.6, so on. So these are all continuous variables, continuous factors. Then we could have categorical or discrete factors. So discrete factors are, for instance, number of people. This symbol means number of people or number of machine. So for instance, you will call machine 1, machine 2, machine n. Imagine that you are trying to do something for the food delivery companies. Okay, then they will say like delivery boy 1, delivery person, not delivery boy, right? So it could be anyone. Delivery person 2, delivery person 3, and then these are discrete. You cannot have 3.2 in delivery. It's either 1, 2, 3 or 6, 7, 8, whatever it is, but it cannot be 5.6, 6.7, whatever that thing is. Yeah, so it could be, for instance, material choice, it could be material A, B and C. So these are the different types of factors that we have discussed, I believe. Sometimes it can also be just binary, for instance. So it can just be 0 or 1 or yes or no. It can. I'm not sure we discussed this, but that possibility is also there. The other one is, I've got the answer. One last request. Could you please house of quality in this course, please? We did discuss?
We do discuss this weekend, week 6.
Okay, I think Alex, I think we are discussing house of quality briefly towards the end of this week. It is there. If it is not clear, you can always raise a request in the online forum and we'll discuss it. What is the range of SN ratio? I think this was a question that was asked in the assignment. What is the range of SN ratio? The point is simple. You can just take as SN ratio as mu squared by sigma squared. Let's not worry about the constant that goes ahead of that equation, 10 log 10, right? That's just a constant. So you're only worried about mu squared over sigma squared. Now you can think what are all will be the values that your mu can take and what are all the values that your sigma can take. So sigma, for instance, sigma itself is not sign dependent, and sigma squared, even if it is sign dependent, will nullify that one. So both of these guys are going to be positive. So you are only talking about positive values here. So what is going to be the ratio in terms of mu squared over sigma squared? So you can, I guess you can answer, and we have already given the solution for this in the assignment. The next question is, how many 3-factor interactions are possible when 6 factors with 2 levels are considered? This sounds like a homework assignment question. So please try not to post assignment questions back here. If you have specific question on the assignment question on why you think that the solution that we provided is not right, we can address that. But don't ask how many 3-factor, don't just repost the question here. Sir, first we are taking ABCD at one trial, we are taking as 1, 1, 1, 1, and in the second trial we are changing. Okay, Varshil.
I think he's talking about conducting experiments here.
Yeah, I get it. So Varshil, I will try to write what you are saying, but what you are saying is unlikely to happen. Can you have 2, 1, 1, 1, 1?
No, if you have for the same trial, you can have.
Can the experiments repeat? No, I don't think so.
If you want to have repeated.
Not trial. He's talking about. Okay, Varshil, there is a little bit of a confusion with respect to the terminology that you are using. So I think you are meaning experiment. When I say trial, it is the number of times you are executing the same experimental setup. For instance, you are saying 1, 1, 1, 1 for ABCD, And then let's say I don't even know what problem is this. This is some problem. Let's say 10 was the trial 1 output. So when I say, and this is for experiment number 1. So then I do trial 2 and then I do trial 3, which means I am repeating this experiment with the same combination of 1, 1, 1, 1. So then it could be 10.5 and I don't know, this could be like some 8.5. I'm just giving some random numbers here. So you go to second experiment, it is 1, 2, 1, 1. I don't know, let's say that it's 15 and this guy was some 14.8 and this guy was some 12.2, something. Some numbers I'm giving here, okay? Then the third trial is unlikely to have 1, 1, 1, 1. It is unlikely that you will have that combination of 1, 1, 1, 1 again. Okay, I don't know where you get this. If you found an orthogonal array like this where the rows are repeating, please let me know. See, the point is, if you are only taking ABCD, this is unlikely. So what you might have done is, like if there is some other AB, AC, AD, BD, all that are there, let's say that there are additional columns, then maybe this combination is possible because the entries for your AB, AC, BD, all those things are likely to change. Okay. Then I'm going to the next question. Varshil, I mean, if you can clarify a little bit more, I can answer. The other one is promote a range is 0 to infinite, as SN ratio is the ratio of square of mean and standard deviation, both positive. 0 to infinite.
What is the question? The range is 0 to
SN ratio, what is the answer that you guys gave?
yeah, we gave the formula specifically and then for that 0 to infinity.
Yeah, so 0 to infinity is the correct thing. I don't know, Pramod, are you asking a question or you are restating what we gave as homework? I mean, in the assignment is not clear. Shivam, unfortunately, I cannot remember or I am not able to access week 2 questions. So, if you can ask a specific question on what was the what you didn't understand in question number 6 of week 2 or question number 9 of week 4, I might be able to address that part. Sir, is a random factor a type of factor?
But it's not
Yeah, I mean, well, you can categorize that as a continuous factor, for instance. Okay, so you can say, when I say temperature as 35 or force as 2 newtons, it is not 2 newtons, but there is some variability that is associated with it, so it's called a random factor. So you can consider random factor as a type of subset of continuous factors. And actually, let me take it back, because there could be variability even in discrete quantities sometimes. That's where you use probabilistic mass functions and all that. So they will take certain values, but then around that value there is variability. So this is still a subset. Randomness is a subset of your factors that we talk about. Yeah. Yeah, I mean, Shivam, I get assignment, correct, but what I'm trying to tell you is I don't have access right now because I'm online and I don't have access to all the documents in the lectures. So if you specifically tell me what was the question, what is your question on the question number 6 in the week 2 assignment, we might be able to help you. அதை எடிட் பண்ணி விட்டுருக்காங்க. கேட்காதா? Ah. How many 3 factors?
We'll post the solutions. Anyway, we'll give us
For that question?
No, we'll give the assignment solutions anyway. It's not better.
Oh, see, okay. Probably now I understand why so many of you are asking the assignment.
We only gave the key, but we don't give the explanation for what it is.
But we will not post it anytime.
Last time, not this time.
Okay. See, what we could probably do is since many of you are asking, I didn't realize until now, is we only tell you right or wrong on your choice. That does not give you ample information on what is the solution or why your solution was wrong. So what we could probably do is this particular example of how many 3-factor interactions are possible when 6 factors with 2 levels are considered. Because if I'm going to write, it's going to take me like 10 minutes on this stuff, right? 6 factors with 2 levels. Huh?
6C3.
Yeah, the simplest way to look at it is 6C3. How many 3-factor interactions, right? So you can just do a 6C3. Yeah. So for instance, for that particular question, you can just do a 6C3 because you are talking about 6 factors and we are asking for 3-factor interactions. So it will only be those many combinations. So if you do that calculations, you will find out what it is.
And levels won't come into the picture.
Yeah. So the levels won't come into picture at that level. That point, not level. So then Mr. Patel asks, are we supposed to answer like ABC? ABC. Yeah, Patel, it's not clear.
Oh, okay. We didn't give you asked for a number, not which factors we asked for. We didn't ask for the list of the factors.
But you would have given options, right?
We only gave number only. Options only. Whether it was 15 or 20 or something.
Yeah, so looks like the options for this particular question had numbers as options. So there was no way for you to answer ABC, ABD, right? Oh, but you cannot answer ABC, ABD because the option that we are given is the number of 3-factor combinations. But your 3-factor combinations are correct. ABC, ABD, BCD, those are the 3-factor combinations. But the question was, how many of those combinations are there? How are we assigning values to the dummy column and on what basis? Okay. Now, Nafi, thanks for this question, Nafil. See, the deal that you need to remember is when you're trying to do orthogonal array, as it was mentioned in the lecture, we don't discuss on how you construct an orthogonal array, if you remember, right? That is slightly out of scope for this discussion. And it also makes sense not to discuss it, or it makes sense, the course makes sense without discussing that, because orthogonal array are already available, especially for manufacturing applications, for design applications, for the amount of factors that you want. Already orthogonal arrays are available. So it doesn't matter whether you are a computer scientist who are trying to look at different combinations in terms of chips and parts that are involved in a computer, or a mechanical engineer who's looking at stress values, or you are looking at the force displacement curve for a car crash. It doesn't matter. The reason that I'm giving all these is the magnitude that we are talking about. For instance, stress, you're talking about certain GPAs, 10 raised to 8, 10 raised to 9. Strains, you're looking at 10 power minus 6. And then if you're looking at computers, you're looking at few thousands. It doesn't matter what your bandwidth is, but still an L8 orthogonal array is still an L8 orthogonal array, irrespective of what is the application that you are using it for. Now, so the orthogonal array itself does not come with a dummy column. It does come with a column. The second step, if you remember that we discussed in the lecture, is for us to assign factors to your columns. Only in that situation, what we end up doing is, we figure out that you cannot run a full factorial experiment, and a half factorial experiment might not be exactly half in a sense, so you will have L16 and then you have L32, but then when you take half of the total number of experiments, you could have something like L12, but L12 is somewhere, and not L12, 12, but you don't have an L12. It will be somewhere between 8, you will either have to go with 8 or 16, but 8 is going to be 1/4 of it. So what you will end up doing is, you will go to L16, but you don't have as many columns to fill, so you leave out certain columns as dummy column. So the dummy column is dummy from the fact that you are not assigning factors to it. It's not, the column itself is not dummy, the column is still there, but you are not assigning factors to the column. That's what it is. Nafil, I hope it clarified. Otherwise, you can be a little bit more specific and I'll try to answer. Otherwise, we can try to take this discussion for the other forum, on the regular web forum. In the old assignment question, in a Six Sigma process, okay. This I think we clarified in the announcement. It is not 3:4, it is 3.4. 3.4 parts per million. But parts per million is part of the question, fail in a million parts. I guess we have discussed this in the, I'll quickly go through the basic stuff. Yeah. See, for instance, the whole process that we are talking about, it follows a normal distribution. That is our assumption, the normal or the Gaussian distribution. So this is going to be your mean and this is your sigma. So what we mean is, by 6 sigma is, this is 2 sigma. Like that, if you keep marching, then you will go to 6 sigma. It's not to scale, okay? Just bear with me. This is 6 sigma. And what I'm going to shade in red, I'm just drawing the right part of it. But you can imagine that this is a symmetric stuff, so there is, there is symmetric stuff and there is a red region on the other side also. Now what we are trying to mean here is, this region that I marked in red should be 3.4 parts per million, means 1/6 or 10 raised to 6. That should be the quantity. What is the quantity of the area under the entire curve? It is 1. For this entire curve, it is 1. And I am talking about 3.4 divided by 1/6 or 10 raised to 6. That is the area that is given here. So if you try to go and use Excel or MATLAB or Mathematica, any tool, and you ask for 6 sigma, the value will be lesser than this. The reason is because it is actually not 6 sigma, it is only 4.5 sigma. This particular value will correspond to 4.5 sigma. That is because we have discussed this a number of times in the course. We want to use a factor of safety for the variability, because today you measured, it will be like this. Tomorrow you measured, it will be like this. Day after tomorrow there will be a shift. The fourth day. So there is something called a mean shift. You want to account for the mean shift. So you use a factor of safety of 1.4. Okay. We started with 4. Anyway, they're asking questions. You have someone else coming up next? No, yeah, fine. Yeah, fine. So yeah. So Patel, sorry sir, problem was writing in question. Got the answer, thank you. Okay, thanks Patel. Varshil, sir, if we have 15 or 14 experiments, then how will we perform orthogonal array, as we don't? Oh, fantastic question. But then it was partly answered in the previous question. But anyway, I'll try to take it. Good. I'm at least glad that you guys are asking these questions because you're thinking through. Yeah, so the point is, now what Varshil is asking is, I have only 15, okay, why I will create a new, yeah. I have 15 or 14 experiments, right? So 15 or 14 experiments. Yeah, bear with my handwriting. So he's asking 15 or 14 experiments. So the idea is simple. What you do simply is you take an L16 and then you dummy 1 or 2 columns. That's it. Okay. Your efforts don't change. Wait a second. The question is slightly different, I think, or the question is wrong. So you're not talking about. Yeah, okay. So, yeah, correct only, sorry. So, because if you use L16, then you have 16 experiments, which means you have, the maximum you have is like 15 factors. You are only taking the first order. You are only taking the main fx. So, you take A, B, C, D, E, F like that for 15 of them. Okay. And, but then the question is, how did you arrive at this number of 15 or 14 experiments? That is the question. So, I've answered your question, but my question is to you is to think through how did you arrive at 15 or 14 is the number of experiments that you will conduct. Okay, think about it. But you are right. We might end up in a situation like this where you will require 14 or 15 experiments, but then you don't have a corresponding orthogonal array. Okay, so if you are looking at 2 levels, then you are okay. It again depends on the levels. If this is 2 level, then you are talking about L16. Otherwise, you have to talk about if it is 3 levels, then it will go in terms of 3. So you can have an L9 or L27, like that you have to go. So in this case, you might take 27 and then dummy about half of them. Next one is, sir, could you send notes? It will be helpful to complete the assignments effectively. This is something that you need to raise with the technical team at NPTEL. I don't recall exactly, but there will be some sort of PDFs that will be shared, annotated PDFs will be shared. Okay? You need to raise this request with the NPTEL, but they will do it when they will do it. I think it's before the exam or something. I'm not sure about that part. But I really don't understand, because you have the video, so you can go back and discuss any point in time, and half of our video time is spent on the slides themselves, so you can pause and look at them at any point. And you just make a note of this. We'll ask the NPTEL team also, when will they share because people keep asking for videos. From our end, we'll try to talk to the NPTEL team to see will they share, and if they share, when will they share it. Okay, so that was a question from Kanishka Ram, and I don't see other questions coming up. We are sort of nearing the 60-minute stuff. We started a little late. I don't mind staying back. If you have questions, please type in, and since we are here, we will take the questions. I'll wait for another 5 minutes. If there are no questions, I'll still wait for 5 minutes. And at the end of 5 minutes, if I don't have questions, we'll close the session. No, Varshil, thanks. I hope your questions were answered. Thanks for coming over. Chirant, I hope I answered your question on the 3:4. It's actually 3.4 parts per million. Deepan, did we?
Yeah, we actually put the weightage of 0.
Yeah. So for this particular question, actually in the assignment, the weightage, because it was an error from our side, it should have been 3.4 instead of 3:4. So we have given a weightage of 0 for this question. So even if you have answered it wrong, you wouldn't have lost points. You wouldn't have lost points. Reference book, you can go to the main page of this of this course, and then you will find it. But otherwise, it is Madhav Phadke is a book for robustness. It is quality using robustness. This, you can go to the main page of the course and you will have the reference book, because this is sort of a slightly different type of a course where you have like 4 different topics that are covered, so there is no single textbook. For the robustness part, you can use the Madhav Phadke's textbook, and there were questions in the forum also, and I answered with that. Okay, so then there are also cheap editions of that, meaning the Indian editions of that are available, and it's a nice book to own actually. That's one thing. And for the design for X, again you have product design for manufacturing and assembly by Boothroyd, Dewhurst, and I don't know whether Knight is there in that or not, but Boothroyd and Dewhurst, they are there, and that also you have Indian editions. And I don't think we subscribe something for sustainability. We don't. Sustainability is just a couple of lectures, I guess, that we have. So we don't have a textbook for that. Quality loss function, Q equal to 15 times y minus 10 squared. What is the target performance? Please explain. 10.
It's an assignment question. Yeah, target performance is 10.
Yeah, so this is a assignment question that was taken. I guess you are just asking that assignment question, but anyway, since I'm here, I'll try to explain what this is. See, just 1 second. But this assignment has been posted, the solutions are posted. Okay. I'm just trying to make sure that I'm not releasing the answer before the answers are posted. Okay. So if you go back to the Taguchi quality loss function, we assume that it follows a quadratic nature. Y is the deviation from your target. Okay, I'm calling my from the target, and L of y is your loss, is the corresponding loss. So what we are saying here is, I need to just erase this to make sure it is correct. Okay, so what we mean here is, at this particular location your loss is 0. So if you give what you promised, your loss is 0. The moment you start deviating from what you promised, you incur losses. The more you deviate, the more you incur loss. That's what this entire quality loss function means. So what it is also trying to tell you is, there can also be different forms of your loss function, right? So you can be linear. So this was the extent by which I deviated, and this is the loss that I had. Whereas you can have a quadratic, you can have an exponential, whatever it is. In this particular case, we have given you a quadratic example. So the target performance in this particular case is y. Y is the deviation, y minus 10, yeah. So this 10 here is what the target performance is, because for instance, if your target performance was 10 here, you need to see how much are you deviating from 10. Sometimes this target performance is normalized at 0. Then you can just say this distance is what your y is. But that's not the case here, because y minus 10, with respect to 10, what is the deviation that you have? So let's say that you had 15 here. Then my deviation is 5. So 5 minus 10 raised to 2. That's what that stuff is. So the 10 is what your target in this particular question is. I hope that answers your question. actually speaking, yeah, I mean, after I saw the screen, because I know what I told in the initial case this is y, but if someone just looks at the figure, it might, this entire stuff is y minus 10 actually. Yeah, it's basically the delta y that we would have used. Okay, so for instance, you can just call this as 15 times delta y squared. The delta y squared is nothing but your y minus 10 in this particular example. That's all. So it's basically the amount by which you are deviating from your target. That's what it is. As sample size increases, the population parameter decreases. How? What parameter?
No, this is again an assignment question, but we didn't write it that way.
I think the formulation of your question is slightly wrong, Patel. Sample size increases, the population parameter decreases.
No, the variation is different. The estimate.
Ah, okay. See, take this example. This is population. Okay. Whereas this is a sample, 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 this is a sample. Any of this can be a sample. But the question is, how good is this sample a representation of the population? The one usual example that I give, I don't know whether I have given in the video or not, is let's say that I am working at a university, someone comes and asks, what is the average height of the students in your university? What I do is I walk across from my department and then I find a basketball court and then I go and measure the 20 people who are playing basketball and then I give. So now let's say that the university has 5,000 students, but I took a sample of 50 students who are playing basketball and then I told that this is the mu of their height. You can understand that the sample is biased to begin with, number one, because they are all basketball players and they are likely to be taller than average. So that's a biased sampling to begin with. So like that, the question is, how good is your sample in representing or in capturing the characteristic of your population? So the question I believe that we had asked is, the variation will go down. So let's say that let's forget the basketball stuff. Instead, what I did is I, across the different years and across the different departments, I picked up 50 students and then I got a mu. So one thing that you need to understand is this mu is nothing but the expected value. That's what statistically it is called. It is the expected value. The point is, it's not the value, but it is the expected value. Provided I had an estimate of my population, then this expected value, this mean that I estimate is expected to meet that one. That's why it's called the expected value, E of x. So if you increase this sample size from 50 to 500, you know naturally that you are converging towards the exact value. And if the 50 becomes, 500 becomes 1000, then you will go even closer to it. So that's why as the sample size increases, the variation in your parameter estimates decreases. The variation or the error in your parameter estimate decreases. So we are going past the 1 hour stuff. I don't mind sitting, but I need to get questions. I can answer as many questions as you want. I'm holding on. We'll wait for a couple of minutes. If no questions are coming up, we'll close the session. Otherwise, until whenever you ask questions, I'll take the questions. Oh, video has lag, yeah. One last doubt of graph in assignment 3. Dev Patel, it's very difficult because I don't have access to assignment number 3, question number 5. If you can tell me what sort of a graph it is, I can tell you what it is. Yeah, I mean, for your kind information, this was recorded a little bit earlier, so I really don't recall what was the question number 5 in assignment 3. We trying to pull the question paper, so we'll try to see. Is it there? Synergistic or no interaction? Okay. No interaction. Okay, so I kind of like not understand. I kind of like got the question. Yeah, I guess we had asked something like this: eta, then A1, A2, A3 are the levels of 3 guys. So these are the 3 different things that we are talking about, right? So if you remember in the beginning of this discussion, I mean this online discussion that we had, we talked about synergistic and anti-synergistic discussion. But in this particular case, if you see, as A1 or A, when it goes from one level to another level, there is no pattern in terms of B1, B2, B3, because they kind of like come down between A2 and A3 also. So that's why there is no interaction. So that is the reason that we have given that solution. Okay, so there is another question. Factors A and B cause variation in efficiency of a vehicle, which is shown in figure. Oh, it's a different question.
No, it's the same question. He's giving the cost.
Factors A and B cause variation in efficiency of a vehicle, which is shown in figure. What kind of interaction does A and B have? So A1, A2, A3 are the levels. B1, B2, B3 are the levels. Yeah.
Since they are parallel, there's no interaction.
Yeah. So the thing is, this was discussed in the lecture. For instance, since they are parallel to each other, there is no interaction. So if you were to I guess that we discussed some strength stuff or something, so you might have something like this. There are 2 levels and then there will be interaction. This would have been A1, A2, and this would have been, and this would have been B1, B2. Okay, so unless the slopes intersect, you don't have interaction. That's what it is.
They can be like slightly, they can be slightly different bent.
Okay, I see what you're saying. So they need not to intersect. Yeah, I kind of made a statement that could be wrong. That's what the for instance, I could have like this. Okay, so then there is interaction because this is for case 1, this is for case 2. Whereas or something like what I told, like you can have this and this could be the other case, it could intersect, or it could go like this, something. But what is happening in the example that we gave you is, it is like this. So there is no interaction in that sense. It just follows the same way. Interaction means when the second factor comes in either at level 1 or level 2, the output either reduces or increases significantly. There is a considerable change. That's what it is. So similarly, someone else asked a question, assignment question, and at that point we told we don't know what it is. So can you see what that question is?
Question need to number 6. Coefficient of variation question. That is
Taken care of.
Wait for
Okay, I'll wait for a minute. If there are no more questions, we'll wrap up. Thank you, Patel, for coming over for the session and taking this course. Please let us know your comments so that we can improve in the next offering. Even this is a recorded input. Correct, huh?
Yeah, registration. Last time it was
Okay, so seems like the. Thank you, Nafil, for being around in the course and asking relevant questions in the session now. So okay then, since there are no more questions, thanks for all the ones who came over and the remaining ones who are going to listen this offline. Thanks for coming over. Any other question, we'll be more than glad to answer. Please post it in the web forum and we'll try to answer it ASAP. Thank you.